Now question number 86. A chemical reaction takes place in a vessel of cross-sectional area 150 centimeter square. Due to the reaction, the piston of the vessel is moved upward by 15 centimeter. Against the external pressure of 1 atmosphere, the work done by the system is. So here we have the pressure 1 atmosphere, that's the external pressure basically. Now, due to the chemical reaction, piston moves upward by 15 centimeter. And further, the cross-section area of that piston is 150 centimeter square. So simply we can find out the volume of the product that is formed during that reaction. And here, if we talk about the work done, that work done is equals to minus P external delta V. Now in this case, what is P external? We know that this is 1 atmosphere into what would be the change in volume? It means the volume of the product formed there is the area occupied by that into height or the distance traveled by the piston, that is 15 centimeter. So it would be minus 2250 atmosphere centimeter cube. Now we can also write it as 2.25 liter atmosphere. Now this is the negative value and this is actually the work done that we have to calculate. Now on the basis of this, the correct answer for this particular question is option 3, and that's why I'm choosing it as the correct option. Further, let's take next question. Question number 87. The amount of heat required to raise the temperature of 75 kg of ice at 0 degrees Celsius to water at 10 degrees Celsius is. It means in this process, basically we are just going to raise the temperature, that is from 0 degrees Celsius to 10 degrees Celsius also, as well as we are just going to change the state also. Ice is getting changed into water and the temperature is also changed during this process. So in this case, the total amount of heat required, let's represent it with Q. It needs two things. One is latent heat for the given amount of ice. So given amount of ice is M, say, multiplied by the latent heat of the fusion process. Along with that, you want to change the temperature also. So in that case, the amount of heat is Ms delta T. What is S here? This is specific heat. Delta T is the change in temperature and M is the mass simply. Now, we have this mass 75 kg. Let's change it in gram. Now, what is the latent heat of fusion that's given in the question? Let's underline it. This latent heat of fusion is 80 calorie per gram. So this would be 80 calorie plus M value is again 75 into 10 raised to the power 3 gram. What is the specific heat of water? This is also given. It is 1 calorie per gram per degree Celsius. So 1 I'll multiply here. Then delta T. What's the change in temperature? It is from 0 degrees Celsius to 10 degrees Celsius. So change is 10. Let's solve this also. This would be 6.75 into 10 raised to the power 6 calorie. And what would be the value in kilocalorie? This would be 6.75 into 10 raised to the power 6 divided by 10 raised to the power 3. So this would be 10 raised to the power 3 kilocalorie. And on that basis, the answer is given here in option 2 that you should choose. After this, it's a turn for next question. Let's check. Which among the following is an intensive property? We have different options given here. First option enthalpy, then entropy, Gibbs free energy and pressure. We should know that intensive property does not depend on the quantity of matter. And now if you look at the given properties, we'll identify that pressure is force upon area. It means it only depends on force as well as area, not on the quantity of matter. While if we talk about other properties given here, all are extensive properties. And that's why the correct answer is given in option 4, and that is pressure. Now, after this, let's take question number 89. Question number 89, which one of the following acids has highest heat of neutralization with 1 equivalent of NaOH? It means we are talking about the process of neutralization where we have 1 equivalent of NaOH and we just want to find out that acid which has highest heat of neutralization. If you look at the given options and if you check this HF, in case of this HF, this fluoride ion is the smallest one and it has very high extent of hydration. And when this HF neutralized with NaOH, 1 equivalent of NaOH, in that case the amount of heat released at hydration energy is very high. It means the hydration energy that is released is very high, and that results in highest heat of neutralization of HF with 1 equivalent of NaOH, and that is why we can easily choose HF as the correct option, and that's given in option 2. And after this, let's take the last question. Question number 90. Molecules in which only London force is present. So if we talk about the non-polar molecule, non-polar molecule always have only London forces. And in the given options, if you look at CCl4, it's a non-polar molecule. That is why it only has London forces. And that's why I've chosen here option 3 as the correct option. And yes, this is the last question of AIATS 2020. Thank you so much for watching.